Basic principles of forensic chemistry as a tool in criminal investigation. Based on my search, there are 7 basic principles of forensic chemistry as a tool in criminal investigation. These principles form the foundation for how forensic chemists analyze evidence and link suspects to crime scenes. Law of individuality. No two objects, whether natural or man-made, are identical. Even items produced in the same factory have unique characteristics that can be distinguished upon close examination. Principle of comparison. Only like samples can be compared. You cannot compare fundamentally different type of evidence. For example of this is hair versus fiber, or human blood versus animal blood. Principle of exchange, as known as Locard's principle. Whenever two objects come into contact, there is a mutual exchange of material between them. This allows forensic chemists to link suspects, victims, and crime scenes through transferred trace evidence. Law of progressive change. Everything changes over time. Evidence must be collected and preserved promptly before degradation occurs. For example, bullet thrusting, tissue samples decomposing. Principle of analysis. Evidence must be properly collected, preserved, packaged, and transported to the laboratory to avoid contamination, tampering, or degradation that could compromise results. Law of probability. The likelihood that evidence belongs to a specific source or that a particular event occurred in a specific manner must be calculated based on all possible outcomes. Principle of linkage. Physical evidence can directly or indirectly link a suspect to a victim or crime scene. Facts don't lie, even when human statements may be inaccurate. Additionally, forensic chemistry as a practical discipline operates on 3 core operational principles. Chain of custody, maintaining the integrity of evidence throughout handling. Quality control and assurance, ensuring accuracy and reliability of analytical results. Documentation. Documentation is to record all procedures and findings meticulously. These principles guide forensic chemists in analyzing substances such as drugs, explosives, poisons, and trace evidence using techniques like gas chromatography, mass spectrometry, and infrared spectroscopy to support criminal investigations in legal proceedings.
Scientific evidence is used to many important ways, especially in fields like science, law, and everyday decision making. First, to support or prove ideas. Scientific evidence helps prove if a claim or idea is true or false. Example, experiments showing that plants grow faster with sunlight. In solving crimes, in forensic science, scientific evidence is used to solve crimes. Example, DNA testing to identify suspect. Fingerprint to match a person to a crime scene. And blood analysis to understand what happened. To develop medicine and treatments, scientific evidence is used in medicine to create safe and effective medicines. Example, testing vaccine before they are given to people. To understand the environment, scientists use evidence to study climate change, population, and natural disaster. Example, measuring air quality to know if it's safe to breathe. To make informed decisions, people and governments use scientific evidence to make smart decisions. Example, creating laws about health, safety, and the environment. In research and education, students and researchers use scientific evidence to learn new knowledge and improve understanding of the world. Scientific evidence is used to prove facts, solve crimes, create medicine, protect the environment, and guide decisions.
Types of physical evidences. First is the corpus delicti evidences. Examples, object or substances which may be part of the body of the crime. The body of the victim of murder, prohibited drugs, recovered from a person, dagger with blood stains or fingerprints of the suspect. Stolen motor vehicle identified by plate number and body of the engine. Number 2. Associative evidences. These are the evidences which link a suspect to a crime. Example, the offender may leave clues at the scene such as weapon, tools, garments, fingerprints, or foot impression. Example, broken headlights, glass found at the crime scene in hit and run. Wearing apparel of the offender and the other articles of the value may be recovered where the crime of rape was committed. So physical evidences, the tracing evidence. These are physical evidences which may be assist the investigator in locating the suspect. Another common types of physical evidences. First is the blood, semen, and the saliva. All suspected blood, semen, or saliva liquid or dried or animal or human present in the form of suggest a relationship to offense or person involved in a crime. Documents. Any handwriting or typewriting submitted so that authenticity or source can be determined. Related items include paper, ink, intended writings, obliterations, and burned on charred documents. Number 3. Drugs. Any substance seized in violation of laws regulating the safe, manufacture, distribution, and use of drugs. Explosive. Any device containing an explosive charge as well as an object removed from the scene of explosion that are suspected to contain the residue of explosive. 5 is the fiber. Any natural or synthetic fibers whose transfer may be useful in establishing a relationship between the objects and or person.
Retrieving physical evidence at a crime scene begins with securing the area to prevent contamination or loss of important material. Law enforcement officers establish boundaries and allow only authorized personnel to enter. Once secure, the investigator carefully document the entire scene using photographs, videos, and writing notes. This step is crucial because it preserves the original condition of the crime scene before any evidence is touched or moved. After documentation, investigators conduct a systematic search of evidence using organized patterns such as grid, spiral, or zone. During this process, forensic technicians collect various types of physical evidence, including fingerprint, blood sample, hair, fiber, and possible weapon. Proper tools like gloves, tweezers, and webs are used to avoid contamination and ensure the accuracy of the collected evidence. Finally, all collected evidence is properly packaged, sealed, and labeled with important details such as date, time, and location. Investigators also maintain a chain of custody, which is a record of every person who handles the evidence. From the crime scene to the laboratory, this ensures the integrity and credibility of the evidence when presented in a court. By following this procedure, investigator can help ensure a fair and accurate investigation.
Historical development of crime laboratories or international development, early beginnings 19th century, forensic science started with simple chemical tests to detect poisons in criminal cases. In 1836, Mars test developed by James Mars, it was the first reliable method to detect arsenic poisoning. This allowed courts to use scientific proof instead of just eyewitness accounts. In early 20th century first crime labs, in 1910, Edmond Locard, a French criminologist, established the first modern crime laboratory in Lyon, France. He also introduced the Locard exchange principle, or the every contact leaves a trace. This principle became the foundation for modern forensic investigations. Further global developments. By the 1920s to 1930s, other countries, including the US, started setting up crime labs. Modern crime labs now include DNA analysis, toxicology, fingerprinting, ballistics, and digital forensics. Local development, Philippines. Spanish era or forensic methods were basic and mostly relied on eyewitness testimony. Only simple chemical tests were used in criminal cases. American period, modern scientific methods were introduced to law enforcement. Early chemical analysis and crime scene and documentation started during this time. Post-independence and modern times, the Philippine National Police, or the PNP, and National Bureau of Investigation, or NBI, developed modern forensic laboratories. NBI Crime Laboratory now handles DNA profiling, toxicology testing, fingerprinting, and ballistics analysis, drug testing. Modern labs also incorporate advanced technology like digital forensics to ensure accurate and court-admissible evidence. That's all. Thank you.